Today we'll talk about Singularity, right? So you might have heard it this from time to time these years, because it becomes very popular, and it's a very powerful container tools that can help you research on the HPC and give you much freedom you would like on the HPC classes as a user. I mean, you don't have any root or sudo privilege, you will then find that you will gain some sort of freedoms with Singularity when run your programs on the HPC. So that's the core part and the purpose for using Singularity. So if you wish to know more about it, welcome to learn it with me today. Okay, so here is the first thing I would like to talk. So why we use Singularity? So if you are HPC users, no matter you are new or old, for many years, and you may find that on a typical supercomputer clusters, you cannot use some commonly used popular Linux command to install softwares. Like you cannot use yum, or you cannot use apt-get as you are doing every day on your Linux PC, because you don't have sudo or root, and you might need to update some system libraries if you find those libraries are out of date on that HPC cluster. You cannot just update them because you don't have you are not the system admins. And also sometimes you want to share your work done on the HPC on your HPC clusters with your lab members or your colleagues, and want them to repeat what you are doing, so to see if they can reproduce the results you have done. And that means you need to tell them how to do the every step they need to follow to install and use your program and use your input. But that might have too many steps or features that they need to follow and catch up. And of course, you can ask HPC support staff for help, so asking them to install something with yum or update some system libraries. But usually, from the user support point of view, we cannot just simply update or install those softwares into a system path, because that might change our fundamental the fundamental software stack, and affect other softwares that has been installed. So usually we don't upgrade our system libraries, and we don't install stuff by yum or apt-get for our software just as you request. Oh, as a HPC user, you may need a tool that can make software installation much easier. So you need a tool that can let you run yum or apt-get, and a tool that can let you freely update any system libraries for the software. And sometimes you might just need a software that is already built and shareable in some free repos. And Singularity is that software. So it offers those features I just mentioned, and it has a free it has a Linux distribution, and it can let you do it by yourself. other than asking any HPC support staff for help. As long as you know some basic Singularity knowledge, you know how to do it by yourself, and once you have a Singularity image, you can share it with your colleagues, so they can use that image to run your what you have built and be able to reproduce what you have done very easily. So let's review the Linux system architecture to make sure how Singularity works. So on every HPC clusters or on every PCs, there is a hardware, of course. And up the hardware, there's a Linux kernel. The Linux kernel is for you to make sure every hardware is powered on and connect to each other, and they are functional. But you also need some others above the kernel, which is the file system. So each Linux system has a file system. You will need your own file system in order to run anything on the HPC cluster or on the Linux PC. And then you add those applications you need into some place in the file system. So now with Singularity, we have or any other container technologies, we have a container launcher based on the native file system. And then we launch our container tools to have a container that has its own file systems, and then we build applications on those file systems. So inside that container, you will have much more freedom than on the native file systems, which usually you don't have any sudo or root privilege. Okay. So how about Singularity? So Singularity is the software providing the container for the HPC environment. So you might have heard Docker. Docker is another container technologies, which is I think is the most popular container technology in the world. Also, Docker can also provide the containers, but inside the container, inside the Docker container, it requires root to build those applications in the container, which is not a good idea in the HPC environment, because for security reason, root is not allowed when running container in the HPC environment. So here's the Singularity container. So container inside that Singularity container, you don't need root to build those applications. That's why we choose to run Singularity on the HPC clusters. And why we use Singularity? Let me add more tips here. So it's not just a secret tool for containerizing those software on HPC, but Singularity can also have many features like natively support the HPC interconnects, such as the InfiniBand, and it can also support those GPU cards, and it can support MPI, because that's very important and common features on the HPC clusters. And Singularity can be shared and transported as a single container image. So there's only one image file to share once it's created. And with that image, you can just share it with your colleagues or lab members and run it even on different clusters. And it can also be integrated with many popular workload managers such as Slurm. and some Singularity features can convert directly within Slurm. Okay, so here's the summary of why we use Singularities. So before Singularity, you cannot use yum or apt-get to install softwares, and you cannot update system libraries such as glibc for your applications, and you cannot easily share the workflow with colleagues to let them reproduce your test results. But now with Singularity, you can use those yum install or apt-get install, or even directly get an image from the developers. So many developers know Singularities, and they have built Singularity images for their software and share it with others, or they have some definition files to tell you how to build a Singularity image, or how to build a Docker image. And then now with Singularity, you can build an image with a newer and preferred Linux distributions. So, for example, your HPC clusters is running on Red Hat or CentOS OS, CentOS, but now you are Ubuntu user and you wish to use Ubuntu. Then in that Singularity container, you can choose to run Ubuntu. So that's up to you, and it usually works well. And now you can, of course, you can share that image to your colleagues now once you have the image. Okay, so I have highlighted the word image here. So what exactly is an image? An image in the container technology is a static file that includes your executable code. So that it has two features. It's immutable. That means once it's created, you cannot just change that image, and it's portable. So it can run on many other platforms or clusters, or as long as the kernel are similar. There is a limitation, which is about the kernel, but other than that, usually you won't see any limitations about where to run it. And you can imagine a container image as a game CD. So once you got that CD, you can play games on your Xbox, or on your friends' Xbox. So it can play on other places. Oh, okay. So that's the first part I would like to introduce. So why use Singularities? Please let me know if you have questions and comments so far before I move to the next session.
We do have a couple questions.
Yes, please.
One is a big knock against using containers in HPC is performance. How can these concerns be addressed?
The performance about the Singularity on the HPC system. Let me see if I understand the questions. I guess. I'm not quite sure if this is a big concern or not, because in my own experience, I certainly didn't test every software inside the Singularity containers, but the one I have tested, I haven't found any significant performance loss when using when put those software in the Singularity in my own test. Of course, my test is limited, but might not apply to everywhere. But I have a confidence that many softwares I have seen I still gave similar performance inside the container. So that's my answer. or if you have any specific examples to say that any performance loss, welcome to let me know, so I can take a look and see if we have a workaround or we have any solution for that. I hope I tried my best to answer this question.
And you've got a few others weighing in on that too. So we do have another question, and this one came in, let's see, at 11:16. Can non-Linux OS be used, like OpenBSD?
Let me see. That's good question, but Singularity cannot directly running on other OSs. I mean, it cannot directly running on Windows or cannot running on Mac OS, but usually it only supported running in the Linux environment. But if you wish to run Singularity on your Windows PC, there's a workaround, and I will mention this later. Or if you wish to run it on your Mac OS, there's a workaround. You just need to build a Linux virtual machine, or use similar technologies to let Singularity run on your PC.
All right, next question at 11:19. What are the advantages of using Singularity over Docker, besides the lack of necessary root privileges necessary for running Docker commands, as you alluded to earlier?
That's a good question. Besides the security reason, I mean the root, I think Singularity, in my opinion, they are quite very similar. they're very similar technology. I'm not. I haven't been able to think about this carefully before. But the bottom line is, if you are HPC user, I mean, wish to have a container, to use a container technology on the HPC clusters, you have to choose Singularity. I mean, that's the bottom line. I mean, I haven't seen any data center that is open to for give users opening for Docker, for running Docker. But those data centers I know that are all allow users to run Singularity. I think that's mainly for the security reason.
Great, and that wraps up the current questions, and everybody else is chiming in too to support these. So thank you, everybody.
Okay, thank you, everybody. Thank you for trying to help. So let me move to the next section. So where to build those Singularity container images? Because usually building those images require you to have sudo or root, but you usually don't have it on HPC clusters. So that's true for at least for those SDSC clusters like TSCC or Expanse. We don't give users sudo or root privilege, or don't let the user build Singularity on our clusters. So there might be some other clusters allow users to create a Singularity containers directly, and but you will need to consult their support staff to confirm. So where to build those containers exactly? So it can be built on your PC or some local server where root permission is available. Also, you can try some cloud platforms that can also provide free Singularity container services, like the Scilab. Scilab is actually a cloud platform provided by Singularity, and Jetstream too. If you have heard this popular cloud computing for researchers, It's just string 2 is it's developed by Indiana University, and it's very popular, and it's not just providing the Singularity container services, but it can use to build singularities images. Okay, so here is just some simple workflow, how to use it, how to build Singularity. So you just install it first, of course, on your PC, and then you build the image on your PC or on the cloud, and then you upload your image to the supercomputer clusters and then run it. So that's it. 1, 2, 3, 4 is very simple and clear. It's nothing hard to understand, I think here. So how to install a Singularity on your PC? If you have a Linux or OS, so you can just use yum or apt-get install if your Linux OS is new. So usually Singularity has been packaged by yum or Debian already, and or you can choose install Singularity from source. And if you have a Mac OS, you can install and run through Linux virtual machines. And if you're a Windows user, you can also choose Linux virtual machine, or you can just use the WSL2. So that's what I'm using on my Windows PC. So once Singularity has been installed, it can be used to build an image by the Singularity build command. So this build command requires sudo. So here is I just gave an example of the Singularity build command, and it's sudo Singularity build, and then your Singularity image name, and where to build to pull the contents for this image. Here, at the end of this command begins with the daughter. It's the external resources where Singularity should download those pre-built images. So in this example, Singularity is trying to download some external resources from daughter, and then build and transfer it to the Singularities. That might be the most commonly resources you will use when building Singularities. And here the daughter, it refers to the daughter hub, and I will mention this next. So what is a daughter hub? The daughter hub, it has the most container images in the world. So you might heard that the daughter it's basically everywhere in the container world. So it can it saves many daughter images contents, and it can. And you can just go to there and search container images without account. You can just search what's that, which software you need. Usually, if you are lucky, you can find the software you need. But generally speaking, please do not simply visit and search and then download. Instead, please go to the software manual or document or developer for the best container images, because many developers have already mentioned those their official image places on their website, for example, on their GitHub. So you just visit their GitHub, and they have already added those instructions about how to get their official Singularity image or daughter images there. So you just follow those instructions and get your image. So once you decided which images to get, you can download, you can let Singularity download those container images from the Dart Hub with the format like this. I list the format here, so that won't take too much details, but it should be easy to understand. Like we tell Singularity is from the Dart Hub, and then the 2 layers is about the username and the application name. Sometimes there only be one name, one layer, as shown in the example, and then a version tag. Version tag is tells Singularity which version Singularity should choose. So here are some examples of this this Dart Hub container. And another source you can think to use is from Nvidia. Nvidia also have its own GPU cloud available for you to download some images they tested officially. So those images contains the GPU enabled applications and all Nvidia GPU labs. It is a private registry, but still on the Docker Hub. It's free to use, and you just need a free Nvidia NGC account to search and pull those images. And I list some details here, and the format is just a little bit different. As I highlighted in red here, you just need to add the Nvidia's private registry tag. And then you can search those images and build in Singularity images according to their tag. And if you are bioinformatics machines, you can consider to get your biocontainers from the biocontainers. So that's the name. That's its name. And the tag I highlighted in red in the example is their unique. Their unique registries. So you can just add the search. Once you search the tags and find what you need, you can then build your Singularity images with this format. And besides directly building images from those Dart Hub or Nvidia or biocontainers, usually you will need to create your own definition files. We call it recipe. So that can also be done by the Singularity build command. And here in this example, I build a Singularity image called elfin.s image from a file called singularity.alpha fold. So alpha fold is the singularity.alpha fold is the recipe name, but you can name it you can name it anything you want. And you can use a recipe when you want to modify an existing image, or you build an image from scratch, or you want to add new features to your image. It can be very flexible once you got to know how it works. And most image should be customized for better run on the cluster. That's my opinion. And you can, for example, you can add binding points. And what is the binding point? We can talk about this later. Or you can set up any necessary environment variable designed for your cluster, and you can use your recipe as a record about how you build your image. So next time you want to build another image, or you want to modify your image, you can just modify your recipe and rebuild it. So, and also you can share your recipe to others to introduce your building process, so others can just say very easily to get how you build your image. Okay, so here is an example of Singularity recipes. So we have some header files. Here is a bootstrap Docker, means it's going to pull some resources from the Docker hub, and from what kind of format it needs. It needs Ubuntu 16.04. And there are some labels that just give some metadata information about this image. And the next part is the post. This part is the main part of the recipe. It can download, install, configure, create new directories, and doing many other things at the image building time. And any environment variables can also be set here if they're needed during the container building time. And the last part in this example is the environment part. This environment part defines the environment variables that will be set at runtime. So it's something when you run your Singularity image, what kind of environment variables will be executed or will be loaded. So here's some other sessions I think is useful, and like the files. For example, if you wish to copy files into the container at the building time, at the container building time, you can add that sessions to copy files to some place inside the container file systems. And the run script session can execute a command when running Singularity run. And the test sessions can run some very basic test at the very end of the build process to validate the container. So how to finalize the recipe, and here's some stories I have been experienced for some years. And the Singularity build may take like 10 minutes or even longer to build a moderate size container images. So there will always be some uncertainties when running commands in the recipes. So for example, unsure which yum install or apt-get install can work, or I'm unsure whether source code compilation can work, and whether I may have some incorrect locations in the container file systems, or I might have some typos or incorrect file name in the command lines. That happens to me all the time when I am building Singularity images. And the bad news for me is the build process will be terminated immediately by any of the error mentioned above. So your Singularity build command will be interrupted by those errors, and you will have to fix your error and then run Singularity build. So if the workflow is like this, like you run, you see those errors, you fix those errors, and then you run those Singularity build command again, and until you see your next error, and you fix your next error and run again, and you repeat that until every error is fixed. that workflow might take you a lot of time, and you might even lose your patience. So that's not good. So fortunately, with a recipe, we might be able to overcome that process. So you can just choose a base container as the starting point, and then create a Singularity sandbox with the image that has the base desired tools. So what is a sandbox? The sandbox is a container with a writable directory. So it's usually it's for you to test how you build the images. And here is the example Singularity. I have here Singularity build, and then add the option sandbox, and then you will have a sandbox for you to test Once this sandbox is created, you then end the sandbox with the command called Singularity shell, and then add the option writable, and then test with the interactive command, just like what you are typing commands on your PC or on some other places. And once you are inside the sandbox, you're typing commands, every command you need to build that to build your software. If the command work, you can add those commands into your final recipe. If not, you will see error on your screen. So you can fix those errors, and then you try to type the command again, and if it works, add it to your recipes. And once you get your final recipe, you can just build your image with the final recipe. So that should be much better than run Singularity build command many times. So here's the example of how to finalize the recipe, and I have some very simple and basic containers created with the recipe. On the left side is just empty Ubuntu 16.04, and then I just created a sandbox with this recipe and end that sandbox. And for example, I then try to install GCC 9. If this command apt-get install GCC 9 works, then I add that command line into the recipe, into my recipe. If it doesn't work, for example, it has some typos, or if the GCC version is too new to be installed in Ubuntu 16, I will get some errors, and I will then try to fix that error. And that's the way we can that's the way we build our Singularity image. So just a quick summary and review. So we use Singularity build to build our Singularity image, and it can be from some online repos, for example, from the Docker Hub or Nvidia NGC, or from the biocontainers, or you can create your own recipes and update your recipe and for your software, and then finalize your recipe, and then build your Singularity image. So that's the Singularity image build sessions I would like to introduce, and I will stop here for any questions. And let me know if you have questions here.
We do have one question. At 1127, does SDSC also support Appertainer? If yes, have you observed any difference between Singularity and Appertainer?
Okay, that's a good question. I would like to introduce the Appertainer at the end of the sessions. And as you may know that the apptainer is a fork of the Singularity, and at SDSC clusters right now we are using Singularity. I mean, it's we don't have both. I mean, but we only have Singularity. So we choose Singularity because that's what we have been using here for years, and we don't plan to transfer to apptainers. But they should give very similar performance in general. In my opinion, I haven't myself, I haven't tried apptainer too much before on other places. So that's just my opinion.
Great. Yuwu, another question has come in. Are we going to go over how to run these containers in Slurm jobs on Expanse?
I think we have some Slurm example scripts using singularities. For example, I know that on Expanse there are when running AlphaFold, we have a Slurm scripts example to show you how to use run AlphaFold with Singularity. So we have several examples like that on Slurm, and actually on the next slide I will might not be the right place to hear, but we have on Expanse there's a location where we save those Singularity exam containers and examples.
All right, that wraps up the current set of questions.
Okay, thank you, Susan. So on SDSC clusters, Singularity is installed at some place, but you don't have to remember those places, but just use the module load to load the Singularities. For example, on Expanse, you load it with module, but on TSCC you don't even have to load the Singularity with module. It's available by default. Okay, so the next session will be an easy part. I mean, for everyone now. So because most of the users I have made, they don't even need to build their own images. They just ask the HPC support staff for help. So once the HPC support staff builds those images and then upload it to the clusters, those users are just run those images. So that's a very easy work for them to do. So next we just learn some base usage of the how to use those images, like the one I'm showing here. We can open a Singularity shell command, so we can enter that Singularity image. Once we enter it, we can just type some command, and now we know that we are inside an image, and of course we can just run the Singularity image with the Singularity run command, and once you run the command, maybe with some options, flags, and arguments, the container will run and give you the results you want. And the next one is execute a command in the container. So we use Singularity execute to execute a customer command within a container. So that example I used actually test image, and then I want to use the Python inside that image to run my Python script. And this Python command is inside the image, but that PyTorch mnist .py, that Python script is outside of the container. So in this example, I just want to use the Python inside the Singularity container to run my Python script. And of course, those custom command needs to be in the path inside the container, which can be set in the environment section in the recipe, or it might have been pre-built inside the inside the container. Okay, so next concept is about the binding point. So Singularity container file system and the native file system share the user's home directory, but some directories and executables in the native file system do not exist in the container file systems. Like what I'm showing here. Inside the blue is the native file system, and inside the container is inside the red is the container file system. They are sharing your home, but other file systems locations inside in the file system are not shared. So, for example, on the SDSC clusters, you have OCs and you have projects directly in the native file system, but they are not available by default inside the container file system. So that requires you to add some binding point when running the Singularity. And if your Singularity version is new, it's like a 3.7 or later, then probably you don't need to add the binding point in your recipe or when you build your Singularity image. But if your Singularity version is old, so then you need to add a binding point first inside the recipe in the post sessions. I gave an example here. So like in my recipe, I just make a directory of the OCs, and then make a directory about the projects, and then use this recipe to create the container. And then later at the container runtime, I need to add a bind option to bind those containers, as I'm showing in this example, Singularity X, and then -b and the OCs and the comma and the projects. So at the container runtime, the Singularity knows that we need to apply these two binding points. So these two locations will also be available inside the container file systems at the runtime. And of course, if we want to add binding points of some files, when creating containers from the recipe, we can create some empty files with the touch command first. For example, in the recipe, use touch /bin/nvidia -smi. So there will be an empty file created inside the container, and then at the container runtime, that command will be available inside the container. And there are some useful binding points. For example, inside for example, for the CUDA executables, if you need to to run those CUDA executables, you can add and apply those binding points inside your container. For example, you can add some binding point for reading some parameters or environment variables from your job scheduler. And you can add some binding point for getting the SSH host keys. And of course, you might be aware of that the Singularity command is very long. So you can make a simple script, bash script, like the example I have here. So a simple bash script can include a long Singularity command. So at runtime, you can just run this script instead of running that long Singularity command. And the options passed to the container at runtime are printed as a single string, as it is here. And you can then run this bash script. And if you want to make use of GPUs, you can use the --NV option to enable Nvidia GPU support, which usually works quite well for the images built from the Nvidia NGC. And here is the AppTenor stuff I want to add at last. So Singularity open source projects now was named to AppTenor. So here are some histories of the Singularity family. And as you may know, that open source project has been renamed to AppTenor, but the Singularity family still exists. And the Singularity products now is provided by Scilabs, and they offer several products like Singularity Community Edition, Singularity Pro, Singularity Enterprise, Singularity Container Services, which is a platform, a cloud platform services, I think. And what we have on our SDSC clusters are still the Singularity provided by Scilab at the moment. And the effect of the name change on using Singularities on our cluster, on our SDSC clusters, basically no effect, because we are still using Singularities, and we choose to use Singularity Pro, and it has been installed on TSCC and Expanse. So it's recommended to install Singularity provided by Scilabs on your local machine if you want to try building Singularity images by yourself on your PC. But the basic use of AppTenor and Singularity are almost the same at the user level. So if you read their user manual, you will find that they are very similar to use. If you're a user, you probably you won't feel many differences, but other than a command, it's different. Now you might need to use the command AppTenor to build your image or to access your image on your local machine. And of course, other clusters may choose to use AppTenor. I'm not sure about other data centers clusters, but you can consult your cluster support staff to confirm. Okay, here are the take-home message. I first introduced why we use Singularities on the HPC clusters, right? So you give you your convenience and freedom you need to build software. You can now choose your own Linux distributions For example, you can choose the Ubuntu you like, and you can choose install software with apt-get or Yum or other tools to install software, and you have some choices when building your software inside the containers. And then we talked about what is a Singularity containers and how it works. So it works as if you are using some you are building and using your applications inside a container, including the container file systems. So when you build and use your applications or build your containers, you are inside container images, you are inside a container environment. So you just use your tools. You have maybe you quite well know how to build that applications on your PC. Now you can just do almost the same thing when you build that application inside the containers. And of course there's some difference about there's some difference when building something inside the containers. And then we talked about how to build an image with recipe, and how to build an image with directly from those hubs, from the Dart hub, from the Nvidia NGC. And if you don't want to build any Singularity images, then the life will be much easier for you. You just run Singularity containers on the classes, and we then introduce how to run the Singularity images. And with the Singularity command, like Singularity shell, Singularity run, and Singularity H. And usually when the image is created by the HPC support staff, they will upload that image to the cluster and let you know run. And usually they know how to run it, right? So you can just use the command introduced by the support staff and run your run your applications accordingly. That's the easiest way to use Singularity. You even don't need to learn much more about Singularity, but of course, if you learn what's going on, what I have introduced today, I believe you will be benefit from knowing more than just run a Singularity command. And yeah, I think that's what I have today. And the last slide is about the difference between the virtual machine and the container, but is just for your reference. Thank you. And please let me know if you have any other questions.